Hello everyone, this is Shomik Deb Niloy, currently studying BSc in Computer Science and Engineering at Bragg University. Here I am going to present about a paper I read. The name of the paper is Language Models or Few-Shot Learners. The paper focuses on the topic of language models as few-shot learners. It explores the potential of scaling up language models to improve their performance in tasks that require minimal training data. The research discusses the use of GPT-3, an autoregressive language model with 175 billion parameters, and compares its performance to previous non-sparse language models in the few-shot setting. The paper also addresses the challenges associated with training and fine-tuning language models, such as spurious correlations in training data and their impact on model generalization. Additionally, it discusses the potential applications of language models as few-shot learners and their relevance in the real-world scenarios. The abstract of this paper provides a concise summary of the main topics and findings discussed in the document. Here is a more detailed breakdown of the abstract. The abstract introduces the concept of few-shot learning in natural language processing, which involves training models to perform new tasks with only a small amount of data. It highlights the limitations of traditional fine-tuning approaches for few-shot learning and proposes an alternative method based on scaling up language models. The abstract discusses the results of experiments using this approach, which shows that scaling up language models can greatly improve their few-shot performance, sometimes even reaching competitiveness with prior state-of-the-art fine-tuning approaches. It also highlights some of the potential applications of few-shot learning in natural language processing. Finally, the abstract concludes by discussing the impact that few-shot learning could have on the field of natural language processing in the future. The introduction provides an overview of the concept of few-shot learning in natural language processing and the limitations of traditional fine-tuning approaches for the tasks. Here is a more detailed breakdown of the instruction. The introduction begins by including the concept of few-shot learning, which involves training models to perform new tasks with only a small amount of data. It highlights the importance of few-shot learning in natural language processing, where it can be difficult to obtain large amount of level data for possible tasks. The introduction discusses the limitations of traditional fine-tuning approaches for few-shot learning, which require large amount of level data and can be computationally expensive. It proposes an alternative approach based on scaling up language models, which involves training very large models on massive amounts of unlabeled data and then fine-tuning them on new tasks with a small amount of labeled data. The introduction discusses the potential benefits of this approach, including improved feature performance and reduced reliance on large amounts of level data. Finally, the introduction outlines the structure of the rest of the document, which includes a detailed description of the approach used to scale up language models experiments to evaluate the performance of these models, and discussion of the potential impact of few-shot learning on the field of natural language processing. Language model meta-learning. The paper discusses the concept of language model meta-learning, which involves training a language model to rapidly adapt or recognize new tasks with only a small amount of label data. Here is a brief summary of the key points related to the language model meta-training. Language model meta-training involves an inner loop, outer loop structure similar to meta-learning in machine learning. In general, during unsupervised pre-training, a language model develops a broad set of skills and pattern recognition abilities that it can use to adapt new tasks at inference time. The inner loop of language model meta-learning involves in-context learning, where the model adapts to recognizes the desired task within the forward pass upon each sequence. The outer loop of language model meta-learning involves updating the model's weights through language model pre-training, which implicitly learns the ability to adapt or recognize tasks defined at inference time. The paper notes that Language model meta-training has been utilized in previous research, including in the form of RL2 and MAML, and that the author's approach of the stuffing the model's context with previous examples is most structurally similar to RL2. The author suggests that language model meta-learning may be important ingredient in the development of adaptable general language systems, although there are still many challenges to be addressed in this area. Overall, it provides a detailed discussion of the concept language meta-learning and its potential applications in future learning in the development of adaptable general and language system. The, the paper describes the methodology used to scale up language models and evaluate their performance in few short learning tasks. Here is a brief summary of the methodology. The authors used to use a model parallel approach to train very large language models with up to 175 billion parameters on massive amount of unlabeled data. They used a combination of data parallel and model parallel techniques to fine-tune these models on new tasks with only a small amount of labeled data. The authors evaluated the performance of these models on a variety of future learning tasks, including text classification, question answering, and summarization. They compared the performance of their models to traditional fine-tuning approaches and found that the scaled-up models achieved significantly better performance with fewer leveled examples. The authors also conducted experiments to evaluate the impacts of the model size and pre-training data on future learning performance. Finally, they discussed the potential implications of these results for the field of natural language processing. Here is a detailed analysis of the results obtained from the experiments conducted to evaluate the performance of the scaled-up language models in future learning tests. The authors found that the scaled-up language models achieved significantly better performance on a variety of few-shot learning tasks compared to traditional fine-tuning approaches. They observed that the performance of the model improved with increasing model size and pre-training data, although the gains were not always proportional to the increase in resources. The authors also found that the model performed well on tasks that required reasoning and inference, suggesting that they are capable of computing complex linguistic patterns and relationships. They noted that models exhibited some limitations, such as a tendency to generate generic or repetitive responses, and that there were still many challenges to be addressed in scaling up language models for future learning. Finally, the authors discussed the potential implications of these results for the field of natural language processing, including the possibility of developing more adaptable general language systems. Overall, the result selection of the paper file provides a detailed analysis of the performance of the scaled-up language models in future learning tests and highlights some of the strengths and limitations of the approach. Overall, the final outcome of the paper is a deeper understanding of the capabilities and limitations of large-scale models like GPT-3, as well as potential directions for future research in the area. The research paper discussed both beneficial and potentially harmful impacts of large language models like GPT-3. The beneficial applications. Language models have a wide range of beneficial applications for society, including code and writing auto-completion, grammar assistance, game narrative generation, improving search engines' responses, and answering questions. Advancement in text generation. GPT-3 improves the quality of text generation and adaptability of our smaller models, which can enhance various applications that rely on generating coherent and high-quality text. Here is the harmful impacts. The potential misuse. The paper highlights the potential for deliberate misuse of language models like GPT-3. Malicious actors could exploit these models for generating disinformation, propaganda, or other harmful content. Issue of bias and fairness. Language models like GPT-3 can inherit bias present in the training data, which can lead to biased or unfair outputs. This raises concerns the potential amplification of existing biases and need for the addressing biases and fairness issues in these models. Energy efficiency. The paper briefly mentions concerns about the energy efficiency of large language models like GPT-3, although it doesn't provide detailed analysis or mitigation strategies in this regard. Overall, the impacts of large language models are both beneficial and potentially harmful. The paper emphasizes the need of studying and mitigating the potential harms while harnessing the benefits of language models for various applications. Here is a relationship with distributed computing. The authors note that the distribution of tasks that a model is trained on we can have a significant impact on its ability to generalize to new tasks. The authors suggest that language model meta-learning can help address this issue by allowing the model to rapidly adapt to new tasks with only a small amount of label data, thereby reducing the need of extensive task-specific training. The authors also note that the distribution of tasks can be influenced by the choice of pre-training data, and that using a diverse set of data can help ensure that the model is exposed to a wide range of tasks and contexts. Overall, authors suggest that language model meta-learning can help improve a model's ability to generalize to new tasks, but that the choice of pre-training data and the distribution tasks are also important factors to consider. That's all about my presentation. Thank you.